Hello and welcome back to my channel. Today I'm going to be giving you a crash course on the Euclidean algorithm and the extended Euclidean algorithm. So the Euclidean algorithm is used for finding the GCD between two numbers a and b equal to some number d. Now most small numbers are pretty obvious because we see them a lot, like 4 and 10 is equal to 2 and GCD of 21 and 18 is equal to 3. Now, the Euclidean algorithm gives us a way to find the greatest common divisor of really, really big numbers. For example, how could we find the greatest common divisor of 17,472 and 10,322? The Euclidean algorithm helps us solve this. So, what we do is we subtract the smaller number from the bigger number until we get the smallest positive integer, or it's equal to 0. When one of the two numbers is equal to 0, we finish the Euclidean algorithm. The other number that's not equal to 0 is our greatest common divisor. Here, this would become 7, 1, 5, 0, and 10, 3, 2, 2, which is equal to, now we subtract the smaller number from the bigger number. Now we subtract this number from this number until we get the smallest positive integer. So we keep doing this until one of our numbers is equal to 0. Then I'm going to go ahead and write out everything. So after continuing on with the Euclidean algorithm, we finally get a 0 here and 26, and then our GCD is then equal to 26. And we're done. Next we're going to talk about the extended Euclidean algorithm. You might also see it called GCD back-substitution. Essentially, we're going to be working with this equation that says that the GCD of two numbers, a and b, is equal to ax plus by equal to d, where x and y are in the set of integers. So the extended Euclidean algorithm is used for finding our x and y values. So the best way to understand the extended Euclidean algorithm is to use an example. So let's use the GCD of 1, 11, and 81. And using the regular Euclidean algorithm, we find that their GCD is equal to 1. So that means that 111x plus 81y is then equal to 1. Next, we're going to be using the Euclidean algorithm, except we're going to be writing out every single step in an equation. So we find that 111 is equal to 81 times 1 plus 31. And then we look at 81, which is 81 is equal to whatever this remainder is, 31 times 2 plus 18. Then we look at 31 is equal to 18 times 1 plus 13. And we're going to keep going until we reach our GCD. And we end when our remainder is equal to 1. So now we have to do the back substitution part. The first step to doing that is to rewrite these equations. So we want the remainder to be by itself. So we're going to say 31 is equal to 111 minus 81 times 1. Then 18 is equal to 81 minus 31 times 2. Then 13 is equal to 31 minus 18 times 1. And then we're going to keep doing this for all of our equations. All right, and now that we've done that, we're going to work from the bottom up, plugging it all the way back up in until we reach an equation that looks a little bit like this one. All right, and now we're going to work from the bottom up, starting with this equation. So we have 1 is equal to 3 minus 2 times 1. Now we're done with that equation. And we're gonna move up here. We have our 2 is equal to 5 minus 3 times 1. And so we're gonna replace this 2 here with that equation. Instead of solving for this, we're gonna combine our like terms. So we have 3 here and our 3 here, and we're gonna combine those 2. So we have 3 times 2 minus 5. All right, and so we've done that equation. Now we're gonna go up to our next one and plug in 3 for this 3 right here. And we're gonna combine our 2 5s right here. So we have 13 times 2 minus 5 times 5. We've done that equation. Now we're gonna plug in our 5 for this 5 right here. 13 times 7 minus 18 times 5. And then we're going to keep going all the way back. So then we continue all the way down, working up to the top. We get 111 times 31 minus 80 times 43. Therefore, our x is equal to 31. And our y is equal to negative 43. And we're done. Thank you so much for watching. This has actually been part of my final project for my math degree. If you have any questions, I'd be more than happy to answer them in the comments below. Once again, thank you so much for watching and have a great day.